Hi everybody, and welcome to Geometry. We're going to continue our discussion about slope today, with our focus being reviewing how to write linear equations using the coordinate plane. The standards we are going to cover are parallel and perpendicular lines, computing, and or using the slope of a line. So today's essential question is, how do you calculate the slope of a line? Now, I had a lot of resources to look at, and I thought I could do all kinds of things, but this one video summed it up pretty well. So I want to show it to you, and then we're going to come back and try some. So let's turn it over to this video, which explains it very well.
Find the slope of the graph of an equation? I only know how to find the slope of a line if I'm given 2 points on the line. Hey, wait, that gives me an idea. I can just find points that are on this line by finding values of x and y that satisfy this equation. Keep track of them in a little table like this. If I put in x equals 0 over here, we'll get y is 0 minus 3. That gives me negative 3. That tells me at the point 0, negative 3 is on the line. Now, if I put in x equals 1, I'll get y is 2 minus 3. That's negative 1. It tells me at the point 1, minus 1 is on the line. Now, if I put in x equals 2, 2 times 2 is 4, minus 3, that gives me 1. So the point 2, 1 is on the line. Now I have a pretty good idea where this line is. Looks like this line is right here. Also have a pretty good idea what the slope is. Use the rise over run thing. We go up 2 and to the right 1, 2 over 1. We think the slope is 2. We can check that out using a couple of these points here. Got these 2 points on the line. We know how to find the slope of a line through 2 points. We take the difference in the y coordinates, divide by the difference in the x coordinates. 1 minus a negative 1 is 2. 2 minus 1 is 1. 2 divided by 1 is 2. Hey, wait a second. Look at that. There's a 2 right here. And the slope came out to be 2. Maybe that's just a coincidence, but it would be awesome if those two always came out to be the same, because then you could just look at this question and go, hey, there's the slope, it's 2. But how can we make sure this will always work out? And we can test that it'll always work out by replacing this 2 with a letter. I'm going to replace that minus 3 with a letter as well. I'm going to replace the 2 with the m, the minus 3 with the plus b. And back here we saw that this 2, that's what the slope came out to be. So we're going to find the slope here and see if it always comes out to be m. And we'll do that the same way we worked through the previous problem. We'll find some points that are on this line. We'll start with our x and y here. If I put in x equals 0, well, then that'll go away and y will come out to be b. If I put in x equals 1, well, then I'll just have m there, m plus b. Y will come out to be m plus b. And now I can find the slope of the line between these 2 points. Take the difference in the y coordinates divided by the difference in the x coordinates. M plus b minus b. That just leaves m. 1 minus 0 is 1. M divided by 1. Sure enough, the slope always comes out to be m. How awesome is that? This is always the slope. Now, of course, you might wonder, what's up with that b? What's so special about it? Well, take a look at this point here. We saw that the point 0b is always on the graph. Well, if the x-coordinate is 0, then the point's going to be right here. It's going to be somewhere on the y-axis. B tells us where the line hits the y-axis. This has a special name. This is called the y-intercept. And we can see an example of this in action right back here. Our line hits the y-axis at the point 0, negative 3. And there's the minus 3. So that's what the B tells us. It tells us where this line is going to hit the y-axis. And some people will use the term y-intercept to mean the point. Some will just mean the value b. I don't care which you use as long as you're clear which one you're using. And because this form of an equation so quickly tells us the slope and the y-intercept, we give it the very clever name of the slope-intercept form. Because you can just glance at this and see the slope is m and the line goes through the point 0b. Hey, that gives me an idea. Imagine we started off with this. We just started off, the intercept is 0b and the slope is m. We started from there, and we used that point slope thing that other guy showed us. That thing is pretty slick. So I want to give it a try here. Line goes through 0b, it has slope m. What happens if we jam this into that point slope form? Well, we got the difference of the y-coordinates equals the slope times the difference in the x-coordinate, x minus 0. That's the point slope thing that other guy was talking about, and we'll get y minus b equals, well, this is just m times x. I'm going to add b to both sides, and out pops the slope-intercept form. That's pretty slick, so we can see that these two are very deeply related. All right, now that we have a good handle on the slope-intercept form, let's tackle a couple problems. We'll start right here. We're going to find the slope of the graph of this equation. We got our shortcut now. Right back here, right? We get the x thing over by itself and we say, bam, there's the slope. So that's what I'm going to do right here. I'm going to subtract this 2x over there, and I'm going to have 9y equals minus 2x plus 9. Bam! See the slope, see the intercept. Looks like the slope is minus 2, and the y-intercept will be the 0.09. Let's check this out. Let's go ahead and, I'm going to go ahead and plot the line. Make sure we're doing okay here. Now, if I put in x equals 0, I can put it in there, I can put it in up there. I'm going to see immediately that y is 1. So 0, 1. Wait a second. I thought this thing was supposed to tell me the y-intercept. That says 9. But it's 0, 1 that works here. What's going on? Look back here and see. Y equals mx plus b. Y equals mx plus b. Y equals, I got to get the y by itself. I've got to divide out this 9. That's the key here in slope-intercept form. We're solving for y. Y's got to be all by itself. The coefficient has to be 1. I can't have a 9 sitting there. I've got to divide out this 9 here. And divide both sides by 9. I'm going to get y equals negative 2/9 x plus 1. Now we see, there it is. There's our y-intercept right there. I can go ahead and stick in another point. What do I want to put in here? I don't want to put in x. Put in x equal, if I put in x equals 1, I'll get y is 7/9. Put in x is 2, I'm going to get y is 5/9. And on and on and on. I'm going to get a line that looks kind of like this. It's not the prettiest picture, but we can see that the slope is negative, and we can see that's pretty close to 0. The slope is going to be real close to 0, and we can see from our slope-intercept form the slope is indeed negative 2/9. All right, one more problem. We've got 2 points here, x-intercept. Well, the y-intercept is where a line hits the y-axis. The x-intercept, yeah, that's where the line hits the x-axis. All right, we can go ahead and plot this. X-intercept there, y-intercept there. We can see this is our line. Goes through these 2 points. And, well, I could go ahead and find the slope using these 2 points, but we can see the slope right here. Up 4 to the right 3, we can see right away that our slope is 4/3. And I can break out that point slope thing, that whizzy thing that other guy was showing you, but if you've got the y-intercept already, you don't even have to do that. This is where slope-intercept form can be really handy. If you've already got the intercept, you can just drop the slope and the intercept right into it. Put my slope in here for m, put the y-coordinate, the y-intercept in here for b, and I get y is 4/3 x plus 4, and we are done.
Okay, lots of information there for you, lots of information. I think the one good thing about that video was he really showed you why. Why does it work? You know, why does it work? Why is slope always M? Why is the B always where it crosses the y-intercept? So hopefully that pieced together in your head a little bit how this is all falling together. It's a good video to go back and watch again if you're not quite sure what's going on. Let's go ahead and review this, and then we're going to practice a couple, and then I'll let you practice a couple on your own. So the slope-intercept form of an equation of a non-vertical line is y equals mx plus b, where m is the slope and b is the y-intercept. So that's a good review. So you can see this. A lot of times you'll hear people say y equals mx plus b, and you're going to wonder exactly what that is whenever you talk about y equals mx plus b. So what you need to learn then is, what does this mean? How do I plug the numbers in? All right, let's look at one here. If we say what is an equation of the line with a slope of 3 and a y-intercept of -5. And if we find out what that is, how do we do that? How do we do that? So what we need to do is we need to look at this and say we have a slope of 3 and we have a y-intercept of -5. We're looking at this y equals mx plus b. Okay? So as we look at that, now we're going to say, okay, here, we know the m is 3 and the b is -5. That's what was given to us. Okay, so let's plug it in and see what happens. So we have y equals 3x plus a -5. Hopefully everybody's with me at this point. Okay, so now that that is plugged in, now we're going to substitute those in and we're going to simplify. So we had the y equals 3x plus a -5, which turns into a -5. And right there is the equation of the line. Okay? Do you see that? Is everybody, hopefully you see that. That's all it is. It's plugging it in. If we're writing the equation for the line, that's what it looks like. Okay? So let's look at this. What's the equation of the line if the slope is 2 and y-intercept is 7? Now we have to look, okay, we're taking this, y equals mx plus b, plug it in. Y equals 2x plus 7. Same over here. Slope is 3, y-intercept is 6. Put it into your y equals mx plus b, y equals 3x plus 6. And then by looking at that, you know that 3 is the slope, and 6, a positive 6, is where the y-intercept, where it crosses the y-intercept at 6. Right? So let's look at it if we're looking at this. What's the equation of this line? And what I did is there's that line, here's the line, and then we have, I came up and over to make the slope, and then I saw where it crossed the y-intercept. So now let's figure this one out, okay? So if we find the slope, well, how do we find the slope? The slope is rise over run. I have trouble saying that. So rise, it goes up 2 and over 1, 2, 3. So your slope on this one, on this line, the slope of this line is 2/3. Okay? Now, the y-intercept. How do we find the y-intercept? Well, we have to find out where does this line cross y. It crosses it right here at this circle. And this isn't perfect, but I'm looking, it's between 1 and 2. So I'm going to say it's about 1.8 because it's pretty close to 2, but it's not quite 2. So if we have that the y-intercept is 1.8, then all we have to do is write the equation that says y equals mx plus b, y equals slope 2/3 x plus b, where it crosses, 1.8. So that's how you find the equation of the line. Okay, we'll go into deeper detail during class, but this is a good way to start, and this will help you in your homework this week. So did we do what we said we were going to do? Can we calculate the slope of a line? We know how to calculate the slope of a line, and we also know how to write an equation in slope-intercept form. All right, have fun with your follow-up problems and with your homework this week, and I'll look forward to seeing you in class. Bye.